this intro lesson called? What's this lesson called? Okay, so logarithms and exponentials are inverse functions of each other. Some other inverse functions that we've talked about before are cubic and cube root, for example. Okay, those are examples of functions that are inverses of each other. And what we're doing today is two different kinds of things. First, we're sort of exploring the idea of inverse functions and identifying whether these things are or not. And then we're going to be given a function and we're going to algebraically find the inverse of it. And then on the back of the notes, we're going to prove that they are, in fact, inverses of each other. So that's the goal for the lesson. Sounds like a lot. It really goes pretty fast. So the first part of the lesson is just sort of the vocabulary or concept part. And I want to start getting into it by first reminding you of something we talked about last semester, okay? That parent function is x squared. And when we defined function last semester, we said something that passes of the vertical line test, right? So this was just for the word regular old function. And this passes the vertical line test because no matter where you drop a vertical line, it passes the graph in only how many places? One. Now, today we're talking about a subset of functions called one-to-one functions. And one-to-one functions pass the vertical line test. They also pass something called the horizontal line test, which is exactly what you think it might be. A horizontal line should pass through the graph in only one spot. Does x squared pass the horizontal line test? No. So while it's still a function, it's not a one-to-one function. And here's why we care about one-to-one functions. They're the only kinds that have inverses, which is the point of the lesson, inverse functions. So x squared does not have an inverse. But like I said, the graph of the cubic function and the cube root functions, they are inverses of each other. And I want you to notice both of those pass the vertical line test, right? And the horizontal line test. They both pass it, therefore their inverses exist, and you could find them if you wanted to. So, and we do want to. We're going to do that here. But before that, look at numbers 1, 2, and 3, and just say yes or no if those are one-to-one functions. And if you answer no to any of them, you have to explain why. So take a moment and do that. And we didn't talk explicitly about number 3, but I want you to use your intuition and see what you come up with. What did you say, class, for number 1? Yes. That's correct. Do we all agree with Hadrian? Yes? Someone said yes? Does it pass the vertical line test and the horizontal line test? Yes. By the way, what function is this that's just been shifted? Square root. That's exactly what it is. What did you say for number 2? No. And if you answered no, you had to give a reason. What does it fail? Horizontal line test. That's right. What parent function is this one? Absolute value. That's right. Number 3, what did you say? Yes, right? So here's the one I wanted you to sort of think about it just intuitively. So vertical line test, you were looking for if the x is repeated. Because if the x is repeated, that would mean it had more than one y value to go with it. So horizontal line, let me start over. Vertical line test, x's can't repeat. Horizontal line test is what? Do you think? The y's can't repeat. Yes. So this is a yes. Okay. So there's that. What we're going to do now is be given a function, and we're going to use algebra to find its inverse function. And here are the steps. Step 1, This right here, f parentheses x, remember that's function notation. It does not mean f times x, right? It's just some symbols for meaning something, and it means f of x. Your first step to figure out the inverse of this function is to replace the f of x with y. And I'll tell you why in just a second. An inverse function is when the x and y values are switched. And when you first saw this, like maybe in Algebra 1, you saw it in different formats. And one of those formats was an XY table. And you don't have to write this down, but just look. An XY table, like you'd have numbers, right? You have numbers there, and you have numbers there. And you would plot those points and connect them, it would make a picture. If you literally took those numbers and switched them, like the x's became y's and the y's became x's, and you graphed that new picture, it'd be the inverse function. It would be a graph that's been reflected over the line y equals x. So what that's going to look like here, so this is not a table, obviously. It's an equation. But the idea of switching the x and the y is still exactly the same. Everything else is going to stay. The 2 is going to stay there. The 3 is going to stay there. But what you're going to do is literally switch the x and y. Everything else stayed the same. Y equals 2x plus 3 just became x equals 2y plus 3. In step 3 now, you solve for y, because this is going to give you your new function. That's the inverse of the original. If I'm trying to get y by itself, what am I going to do first to both sides? Subtract 3, exactly. So go ahead and write that down, minus 3 to both sides. But my y is still not by itself. What do I have to do to it? Divide by 2. So now x minus 3 over 2 equals y, but that last step says to write this instead of y. Does anybody remember what this notation means? Yeah, it means the inverse function. It looks a lot like it's saying f to the negative 1 power, but it's not a power. It's not an exponent. It's just notation. We've taken the inverse, or we found the inverse of the original function f. And so it's a way of saying they're still related to each other, but they're not exactly the same. And so that's your inverse function. If you look, now it's not all, this is, if you notice, this one up here had a plus 3, a times 2. This one has a minus 3, a divide by 2. That's not 100% going to work every time, but it is a way of sort of checking yourself. Does this kind of look like I've done the opposite of everything that was going on up there? It's a clue. You can't rely on that every time, but it's a one way of helping you out. You try number 2, please. Okay, here's what you did. I think this is what you did. You put y in for f of x. Who did that? Yes? Yeah? And then, did you switch to x and y after that? Right? Thank you, Sean. And then what? That's 5. And I've been seeing students stop here all day because their brains are rusty. They try to divide by 3, try to divide by 1, try to divide by y, or cube root. Okay? You want to get y by itself. It's currently being cubed. How do you undo cubed? Cube root. And you do that to both sides. Just like how we do square root to get rid of square. Be sure that your plus 5 is inside your radical because it's part of that. And then instead of equal to y, I want you to use your inverse function notation. Okay, f to the negative 1 over x, or of x, sorry. I'm just making up stuff. All right, hold on. I'll be right back. Don't take out your phone. Oh my gosh. Okay. On the back. On the Dukes. Anybody ever watch Dukes of Hazzard? Has anybody ever? That's what they always used to say. On the. Okay. So on the back, we are verifying that the inverse function we just found is indeed the inverse of the original function. Now, we know that's true because I wouldn't have been moving forward if we got the wrong answers. But we're going to pretend like we don't know it's true. And I'm going to show you how to use algebra to verify that it's true. If I say it's true one more time on the screen. So here's what we got from a second ago. I don't remember, ma'am, please. On number 1 from the front, the original function was this. And our inverse function was this. So here's how you use algebra to prove. So let's say you got this and you wanted to check it and see if you were right. Here's what you would do. You would take this function and plug it in here. You should get x. Then you would take this function and plug it in here. And you should get x again. I'll say it. I'm gonna say it again. This function plug in here, do your math, you should get x. This function plugged into this one, do your math, you should get x. If you get x both times, you've proven that your inverse was correct. Now I'm going to set this up for you, and then I have some of this vocabulary notation that I want to explain as we go. But let me start a little bit more simpler than that. Before I talk about plugging one function into another, here's a smaller problem that we remember how to do. If I have this function, f of x equals 2x plus 3, and I ask you what f of 2 means, what would you say? Okay, so let's listen to those words. That means you plug in 2 for x. Okay, that's called evaluating a function. But what I just told you to do was instead of plugging 2 in for that x, what we're going to do is take this entire thing and plug it in for x. And so here's how that notation looks, and it's something you need to be familiar and understand what it's asking you to do. So instead of 2 plugged in for x, instead of f of 2, I want f of the inverse. Another way of writing this would be f of x minus 3 over 2. And we're going to do this in both directions. But let's just look at the math for this one first. So I'm going to my original function. I'm taking all of x minus 3 over 2 and only putting it where the x is, right? I'm plugging it in for x. That 2 stays there, that plus 3 stays there. So here's how that looks. 2 times x, which is now this. X minus 3 over 2 gets subbed in there. And then the plus 3. When you use another function as the input for a whole other function. This is called a composition of functions. So if you hear me say that, that's what I'm talking about. Instead of a number as an input for x, we're using a function or equation as an input for x. Okay? And this is the notation for that. So now I'm going to do the math here, right? Which means you have to follow your order of operations. You have to think about P, not whether you have to or not, but P for parentheses. Inside here, there's no more math you can do, right? That's as simple as it gets. So P doesn't apply. E is for exponents. Do you see any exponents? No. So M is for multiplication, and I have a multiplication. I have 2 times this. What's going to happen here? The 2 cancels out because there's a 2 on top and a 2 on bottom. That leaves me x minus 3 plus 3. So we did the multiply. There's no more division. Now we do addition or subtraction. That means this minus 3 plus 3 cancel out, leaving me x, which is great. If it equaled something different, that would mean either my math here was bad or my math finding the inverse was bad. Okay. But there's 2 parts to this whole process. What I did here was take the inverse and plug it into the original. You know what I have to do now? Take the original and plug it into the inverse. And here's how that looks with all the different notations. I'm taking the inverse function. Whatever goes in here is what I'm plugging in. I'm plugging in the original, f of x. And the reason why I'm like belaboring this point about how to write it is if on your quiz it tells you, find this, I need you to know what that's asking you to do. Okay? It's saying you're taking your inverse function and you're plugging in the original function. Whatever's inside is getting plugged in. Another way of writing this is just, what is the original function? It's 2x plus 3. Those things mean the same. And so here's the plugging in step. I'm taking 2x plus 3, I'm plugging it in for the x right here. The minus 3 is going to stay on top, and that 2 on the bottom is going to stay there as well. So here's my 2x plus 3 for x, and then the minus 3 over the 2. And then when you're simplifying fractions, you have to do order of operations on the top separate from the order of operations on the bottom. Bless you. Before you can start canceling stuff. Meaning you can't do this. You cannot do, it's going to feel very satisfying, but it's bad math. Are you ready for some bad math? You cannot do that right here. You can only cancel stuff that are factors. Factors are things that are being multiplied. This is being added to 3 and subtracted from 3. It is not available for the canceling yet. So here's what you have to do instead. Looking at the numerator, following order of operations, what do I need to do first here? No, that's not a it feels like a multiplication, but it's not. It's a minus 3 on the outside. It's not times a negative 3. It looks like it, because people have been telling me all day to do distributive property. This right here. That's the first thing you do. Those cancel, leaving me 2x over 2. Now you can cancel the 2's because they're factors. They're not being added or subtracted to anything. This 2 is strictly being just multiplied by that x. So now they cancel. And now you get x. And it checks. Okay. And just as a heads up, let's say you watched me do this and you're like, I have no idea what she did. I'm never going to learn that. She can't make me. And you decide on your quiz or test that you're just going to put like nonsense. Nonsense, 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 X check at the end. That's not going to work for you. I'm looking at your math to make sure you did it correctly on the, I mean, you're welcome to try it. I don't catch everything because I'm not a robot. But just know I'm looking specifically to make sure your simplifying was correct. So just be careful about that. You try number 2 from the front. So here's the, oh, I'm sorry, may I borrow this paper? Thank you. Here's the original function from number 2. And the inverse function, and you are going to do this process. Substitute this one into that one, and then substitute this one into that one, vice versa. Simplify, and you should be getting what at the end? X each time. So take a few moments and try that. So I'm going to take the inverse and plug it into the original first. So that notation looks like this. Plugging the inverse into the original. So where there's an x now becomes this function. And that x is cubed. How do y'all feel about this? You got everything? This looks just like this? Parentheses, there's nothing else I can do in the parentheses. Exponents next. That's this cube. What happens to the cube and the cube root? Cancel, leaving you the radicand inside, the x plus 5. Then you bring down the minus 5. Wait, so you did the exponents, then you do any multiplication or division. There are none. Then you do addition or subtraction, which is right here. Those are gone. Leaving you x. Are we done? No, there's a whole second thing. Now you have to do the vice versa part. So the vice versa part says now you take this function and plug it in to that one, where that x is. That notation looks like this. Take the original, plug it into the inverse. This one you have to be careful on. This is another example of you're going to feel like you did it right, and you got x, and then I'm going to circle it for incorrect order of operations. So let me show you how this goes. So I've got my x cubed minus 5 in place of the x, and then plus 5 right there. Guess what you can't do right now? Who did that first? I mean, you don't have to raise your hand, but you have to think about it. If this was your first step in simplifying, it's bad math. It's wrong. You'll look like you still got the x, but you got it under false pretenses. So this is not going to work for you. Here's what you should do first instead. Whatever's inside the radical, that's a grouping symbol, the radical. You have to simplify inside there perfectly before you take the cube root. So what's going to happen first is the minus 5 plus 5. And now you've got the cube root of x cubed, which leaves you x. And now it checks out, okay? So that's good math.